a couple of words about ElectroKnox. And is Brian on?
Brian is here. Also, this is Xinlei.
Oh, Xinlei, hi. Welcome. Nice to see you. Brian?
Nice to see you, Howard.
Is Brian not on yet?
He's here. He's in the room with me.
Oh, okay, good. All right. So ElectroKnox has created a platform, as I understand it, software platform, operating platform for electric vehicles. And I'll let Brian and Xinlei explain more, but it sounds like they have some traction and they're meeting an obvious need. So please take it away.
Will do. Can everyone see my screen? Okay, it says that it can't. Great, thank you. Good afternoon, ladies and gentlemen. Just a quick self-introduction. I'm Xinlei Chu. I'm COO of ElectroKnox. Brian and I co-founded the company last June. Our goal is to accelerate the transition to software-defined vehicle in the automotive industry. To talk about that, I wanted to kind of talk a little bit first about the changing that's happened in the last few years in the automotive world. Cars, automobiles are evolving from sort of the mechanical machines to connected vehicles as devices because of autonomy, connectedness, electrification, and the overall consumer demand to see more features and connectedness in vehicles. And that demand has generated some challenges for the automotive world, for the OEMs in particular. And some of the pain points that we've observed is, for example, developing modern software and based on capable, powerful hardware for new EE architectures for the new vehicles, and establishing technical independence from traditional suppliers to compete against new entrants in the EV market and large companies such as Apple and Google that are entering the automotive market as well. So Brian and I met at Byton. We were at this EV company for a few years. We worked together, and from the sort of OEM perspective, we were producing an electric vehicle. From the perspective of an OEM, we saw these challenges firsthand. One example was that in producing the Byton M-Byte, one of the teams wanted to add a new feature to the vehicle, and the typical traditional way of doing that is, once the need is identified, the OEM works with a supplier, add a new hardware ECU electronic control unit, and the supplier would go away for a few months to develop both the hardware and the software that's tightly coupled, specifically developed for that piece of hardware. The exchange between the OEM and the supplier on that one unit would take months, and the cost is sky high. In addition to that additional unit, other units that are communicating with that particular unit also has to change. So it causes this domino effect of high costs and a lot of resources being dedicated to just adding one function. And that's one of the reasons that having software-defined vehicles has become such a trend in the industry, that has seen the number of ECUs in a single vehicle go from a few handful to over 100. I think some of the more advanced luxury cars have over 150 ECUs. And so using software to define vehicle functions has become very, very attractive in terms of cost savings, flexibility, and the ability to go to market very, very quickly. And that's part of the industry trend in terms of software, but the software has to run on hardware, and the traditional automotive hardware cannot support this level of software complexity. So high performance computers are becoming the cornerstone for these newer vehicle architectures. And on the right-hand side, I have taken this diagram out of a McKinsey report, where today a lot of the automotive OEMs are moving away from the traditional distributed, every ECU doing one or two specific things and communicating just ad hoc with whichever ECU it needs, to a centralized architecture. And more of the OEMs are evolving into domain controllers, domain-based architecture. And in the near future, the vehicle architecture is becoming zonal. So Tesla in particular has both pioneered and significantly benefited from these newer architectures to go to market fast with lower costs and be able to offer features, vehicle features and applications that let them stand out. And the advantage, of course, to the OEMs are, besides the ones that I've mentioned, is also that the entire vehicle development process becomes a lot more efficient, very simplified, and allows the OEMs to gain much more control and ownership of the vehicle software architecture, and even just having a whole vehicle architecture, a software architecture, which isn't the case right now. A typical OEM owns about 10% of their vehicle software at this moment. And the new software ownership will also allow the OEMs to establish their technical independence from the suppliers that they have so heavily relied on. And so this new industry trend, of course, created a huge unclaimed market. By 2023, the vehicle compute, both hardware and software market, is about $500 billion. Just 5% of that is $25 billion. And at EK, we're only targeting about 20% of that 5%. So in the next 5 years or so, we're looking at a potential market or potential revenue of about $5 billion. So the way that we are approaching that, of course, is from our experience working at Byton. We identified this market gap of both the lack of powerful hardware as well as a software platform solution that would enable all of the automotive OEMs to be able to do that. And we're specifically targeting electric vehicles because that is the future of the entire industry. And so if you think of Tesla as the Apple equivalent of the automotive world, we are trying to create a Android solution equivalent for the automotive world. And our solution includes both a software piece and a hardware piece. We're mainly software focused. We do have a reference design for our hardware because we have the expertise in-house to do such a design, but we are not focused on producing hardware. We are offering that up as reference design for the clients that have such a need. And our software is designed in such a way that it can run on non-EK hardware, on third-party hardware. And I'll mention that a little bit later. We actually have a paying customer right now that we're running our software on another supplier's hardware. And so a little bit more details on our solution. The middleware stack we created is open, standard-based, and API-driven. And basically what that means is anyone who can program in C, C++ can use our software to create features and applications for vehicles. And that's not usually the case. That has not been the case or available in the automotive world in the past. The industry has been fairly closed, especially in software development for vehicles. The requirements so far has been that software developers for vehicles has to have very deep understanding of vehicle architecture, has to understand a lot about automotive, and uses very specialized, super expensive tools to create software for vehicles. And our goal in creating this this middleware platform is twofold. One is to solve the basic, some of the shared functions that all vehicles must have. And in addition, to offer this open platform for software development to enable more of the software developers to be able to develop for automotives. And this actually opens up an entire talent pool for the automotive OEMs, because the software talent in the automotive world has been has had a huge shortage. And we're hoping that actually we're enabling that particular challenge to be overcome. And this is just at a very high level, our software solution. The layer of hardware abstraction actually hides away the complexity of the underlying hardware, which enables OEMs to really develop software independent from the underlying hardware. And as it often happens in the industry, sometimes the hardware has to change, the supplier may have to change. And in the past, what would happen is the entire stack of software has to be shaken up and redeveloped, recreated because of that change. And using our solution, the software can continue to be developed at the same time as hardware and not be affected by the change of hardware. And as I mentioned earlier, our data and service layers offers the shared functions that all OEMs have to address, but oftentimes it's the foundational features that, when done well, nobody notices, but if not done well, the result can be disastrous. So our SDK is also based on the industry standard network description files, and can be created very, very quickly for our clients to build and focus on building the brand distinguishing features and innovations that helps their brand to stand out in the industry. And I should mention that our software is both hardware agnostic, so it can run on any hardware that is powerful enough to take advantage of our software features. It is also cloud agnostic. A lot of the OEMs want to control their vehicle data and maintain that ownership of the data. And our platform can plug into any of the OEM's cloud infrastructure, whether it's their custom one or AWS. We're actually working closely with AWS on creating a use case study right now. And just to mention very, very quickly, this is our reference design for the hardware. It we support both as FPGA and ASIC platform, and the FPGA design has actually been featured in a Xilinx use case studies in June this year. And so all of those things to put together, our experience in the software industry, hardware, computer hardware, as well as automotive, and the solution that we have created puts us in a very, very unique solution position in the market, where we are right at the intersection of a lot of the other the suppliers that they offer, but we are offering a solution that would solve all of the problems that I mentioned before. And in comparison to some of our competitors, here is our advantage and some of the features that I mentioned earlier. And as Howard introduced, we do have paying customers. So ElectroKnox was established last June. In the last year and a half, we have gained several paying customers, and the usage of how they use our products are very different. We have a contract to have our software run in a 2022 production year electric vehicle. We also are talking to a customer that are looking at both our hardware and software solution for their 2022 and 2023 production year vehicle. And the reason that they're able to do that on such a short time frame is because of the flexibility and power that we offer to allow them to create software-based vehicle features in terms of virtualizing a lot of the functionality that required specific hardware electronic control unit in the past. Our hardware also has been selected by one of the OEMs to use as a multi-use device within not just the production, but also as part of vehicle development and testing process, so that we're not just looking at being in vehicles, but also as part of their vehicle development process.
Xinlei, we're about to run out of time. Do you have a couple other slides you want to quickly?
Yes. So we also have a plan to offer cloud features to virtualize and simulate ECU functionality and creating developer tools. Our solution can be used not just in the automotive industry, but also heavy machinery and agriculture. Our team came out of the Byton Smart Gateway and telematics development unit and have been working together for several years already. Here is a very conservative projection of our revenue projection based on our existing customers. And we are looking to raise $5 million right now to grow the team and scale up and support our customers and do business development. Thank you.
Great, thank you so much. Can I just ask a quick question, Xinlei?
Yes.
So you said that you have some traction with several customers. I'm just curious, are you seeing easier traction with, say, these new insurgent or new leapfrogging type electric vehicle companies, or are you actually getting traction with some of the more legacy players?
We are actually attracting both. It's a little easier to sign contract, especially production contracts with the new EV entrants, because they are more nimble and agile and can respond a little bit faster. The more traditional companies tend to take a little bit more time because of their organizational structure.
Right. What about geographics? Where are you seeing more traction? In the US and Asia and Europe?
We have the customers that we have are in US and Europe mainly. We haven't really talked to we're just starting to talk to some of the China players right now.
Okay, very interesting. Anybody else have any questions? We are sort of running out of time here. Okay, well, thank you so much for the very complete presentation, Xinlei.
Thank you so
I
much.
look forward to seeing one of you. Is it you or Brian that's going to be in the main event in Bonny Doon?
Brian will be attending in person. I'll be online.
Okay, excellent.